Hi guys, welcome back to the QSC channel. Today we are going to be doing the Physics Week 7 quiz for the AMS tomorrow. So let's get started. Consider the forces acting on a triangular lamina that can rotate about vertex A. So just to keep in mind, vertex A is your axis of rotation or fulcrum, same thing. Which of these forces will produce a turning effect on the triangle? So just a note to keep in mind here, any force acting on the axis of rotation, there is no turning effect on it. That means the turning effect is 0. So keeping that in mind, let's take each of the forces. Let's start with F1. Since F1 here, it's acting on your axis of rotation, so that means it's 0. You can cross that off, no more turning effect. We'll take also F4. Alright, we extend it to its lever arm. Yes, it's also acting on its axis of rotation, so we can cross that one out too. And we take F5. Yes, that is normal. It's not acting on its vertex right here, so that is, it will produce a turning effect. Same thing with F2. It's not acting. Even if you extend it, it's not going to meet at your fulcrum, so it will produce a turning effect. And same thing with F3, your lever arm, which is the line that you extend. It will not intersect your axis of rotation, so it will have a turning effect. So yeah, next question. The moment of a force, okay, so a force F is applied to a plank that can rotate about the fulcrum A, as shown in the diagram below. So A is your axis of rotation. And now here we need to use the right hand rule. So just for you guys to understand, imagine this is your hand. Alright, this is your right hand, this is your thumb. Alright, what you have to need, I know the drawing is bad, what you have to do is use this side, the one with the pinky, and you have to put it on your axis of rotation. And then those fingers, sorry, my bad, you're gonna have to direct them this way, this direction. You will realize that the thumb is pointing at you, alright, and this means out of the plane of the picture, so it's going directly at you. And always this you need to memorize: if it's going at you, then it's going to be positive; if it's going inside, then it's going to be negative. That's it. Next question. Let me just erase this. Okay, drag and drop the equation that relates the moment of a force to the distance. Okay, so this is just purely memorization. The moment is equal to the force times the distance perpendicular to the origin. So imagine you have the stick right here, and this is your origin, this is a force, just so you understand what the rule means. So it's going to be equal to the force right here times the distance that is perpendicular to the lever arm. The lever arm is the imaginary line, and the distance, what we mean here, is this distance, the one that is perpendicular to the lever arm. So this distance. And that's it. You just have to memorize it. Next question. The moment of F about vertex A, also keep in mind that's your axis of rotation. The moment, we know it's going to be the force times the distance perpendicular to the lever arm. So it's going to be 20 times, this is equal 20 times the distance of the lever arm. So we're going to extend the force. It's going to be this, that is perpendicular, which is 60 centimeters. But here we want it in meters, so we make it meters, divide by 100. So you get 0.6, and you get 12. Next question. Alright, so we have here is a couple. We want the moment of a couple. Now couples are a special case. So the moment of it is the force of any of the forces. They both act in the same direction. Just a quick note as well. Counterclockwise, counter is going to be positive, and clockwise is going to be negative. So this is positive, this is negative, just for information for the next questions. So for couples, it's a really different case. So the moment of them is any of the forces, they're both fine, they're both in the same direction, same sign, same magnitude, times the distance between both their lever arms. So we extend the lever arm here, extend the lever arm here. Wow, we have 2 centimeters, which is the distance between them. Well, here we want it in meters again, so it's going to be times 0.02, and you'll get 0.3. Wait, let me just make sure. 15 times 0.02. Yes, 0.3. Next question. This is just memorization as usual. The quantitative measure of a turning effect of a force is called the torque, or you can say it's the moment. But here there's no moment, it's just called torque. You have to memorize it. Next question. Okay, this you just need to know. They want the maximum torque. How can you get the maximum torque and the maximum turning effect? So there are 2 factors that influence it. One is the perpendicular distance, as I said, from the origin to the lever arm. So generally, the more the force is further away from the origin, the more the turning effect. But here, the forces are all from a single point, so that does not matter here. And secondly, the direction of the force. The more it is closer to being perpendicular to the lever arm, alright, the more the turning effect. So here it will be 1, since it is in fact perpendicular. It will give you the maximum turning effect, and that's all you need to know. 8. The magnitude of the moment of the force. Even here they told you counterclockwise, which is this direction, is going to be positive. Just keep that in mind. So, okay, the magnitude of the moment of the force acting on the body. So we know the moment is equal to the force. The force is 20 newtons times the distance that is perpendicular to the lever arm. Here they already extended it for you, and they supplied you the distance, so it's going to be 0.2, and that will be 4. Just multiply it. Next thing, the body is rotating in the positive sense of direction. Why? Because the force is directed clockwise, so you can imagine it as it's gonna move this direction, which is counterclockwise, which is positive. Just need to imagine it. Wait, hold on, let me plug in my PC. Alright, we continue. Question 9. Select the picture that represents forces forming a couple. So what you need to know, when a couple is formed, they have to be equal in magnitude. They have to be opposite in direction. They have to be as well, their lever arms have to be parallel. Actually, they have to be parallel and non-coinciding. What does non-coinciding mean? It means that they're not on each other. So for example, if you have this force and this force, their lever arms are into each other, they are coinciding. So let's check the options. Here they are not equal in magnitude. Here they are not, their lever arms are not parallel, as you can see, so no. Here they are not in opposite directions, so no as well. Here their lever arms are coinciding, so no. And this, let's check it out. Opposite directions, check. Equal magnitudes, check. Lever arms are parallel, check. And they're not coinciding, so this is the right answer. Next question. Okay, so we have a force F of magnitude 40 newtons is exerted on a square lamina of sides 2. So you can just basically say this is 2, this is 2, this is 2, this is 2. And here they say P, R, S, T are all midpoints. So this is 1, this is 1, this is 1, and etc. This force that they exerted creates a moment of negative 40. What does negative tell you? That means it is in the clockwise direction. So it's going to be this way, clockwise. So by knowing this, we can immediately eliminate P, and we can immediately eliminate R. Sorry, what's 3? R. So it's going to be like this. This is counterclockwise, which is wrong. So we immediately eliminate P and R. So what we have left is T, S, and Q. Here they give you an important information. So the moment, which is negative 40, is equal to negative 40, which is the force. Why negative? Because as we said, it is counterclockwise, so it has to be negative, times the distance, which we don't know, but we can deduce actually, divide both sides by negative 40, so the distance has to be 1. This really tells you a lot, because if the force was on the edges, okay, then the distance would be 2. So we can't really use Q. Why? Because firstly, in any of those points, it would have a distance of 2 and it will not produce negative 40. Alright, so the only options left are, we exclude this, S and T. That's all. Next question. The net moment of these forces. So basically what the net moment means is the addition of all the forces. Keep in mind, you have to make sure that the directions, you have to put negative if it's clockwise, and positive if it's counterclockwise. So let's begin with, and also keep in mind, point A is your fulcrum, axis of rotation. Great, so let's start with F2. F2, if you extend its lever arm as they extended here, it's going to be intersecting A, and that is already, we know it's going to produce no turning effect, so it's going to be 0. Plus, let's start with F1. So F1, we already know it's 8, and we know it's going to be counterclockwise, so it's going to be positive. It's going to be positive. 8 times, we extend the lever arm. This is your distance, that is perpendicular, so this is 6. This is going to be 6. 8 times 6. Plus, now we need the force of F3 here. We know already it's 4, but it's not actually 4, it's negative 4. Why? Because it is counterclockwise. If you imagine you had a box and you put it and you pushed it that direction, it's going to move this direction, which is clockwise. So it's going to be negative 4 times. We extend the lever arm as usual, and we check the perpendicular distance, which is this part, which is half 10, 5. Great. Now all we need to do is simplify. It's going to be 48 minus 20, and you'll get 28. Alright, next question. Okay, this you also have to use the right hand rule. So you're gonna have the part between your pinky and your wrist, that part, and you're gonna put it here on the screen, yes, and then extend your other fingers, your index, middle, and ring fingers, into the direction of F2, and you're gonna see that your thumb points at you. And as we already said, since the thumb points at you, it's going to be positive, and it's going to be out of the plane and into you. For F1, however, it's the opposite. Alright, if you put it here, you're going to realize it's hard. You just need to rotate your hand. Alright, if you rotate correctly, it's going to be like this, and the thumb is going to be going like this. So it's going to be going into the plane, and that is negative. And if you're confused what by convention means, is that it's just they just sat together and made an agreement that if it's going into the plane, it's going to be negative, the turning effect I mean, and if it's going into you, it's going to be positive. That's all you need to know. That's what convention means. 13. A person is pushing a box across the rough horizontal floor. Okay, the box gets stuck at the door stepper as shown in the diagram below. So, which of the forces acting on the box will produce a counterclockwise moment on it? So, you can tell me first, let's try the normal. But in fact, that will produce a counterclockwise force. So, not clockwise. So, let's try the friction maybe. It opposes motion. So, it's also going to give you counterclockwise. Alright, so let's actually try the pushing force. Alright, here. So, also, it will be counterclockwise. So the only thing left is weight. Weight actually produces a counterclockwise force, which is correct. And since it is clockwise, it's going to be negative by convention, as they said. That's all you need to know for this question. Yes. Alright, question 14. Now, when you look at this diagram, don't panic. It's easy, it's simple. All you need to know. Now, if you realize here, they all said about A, so A is your axis of rotation. This is your fulcrum. Let's take force 1. Where is force 1? Force 1 is here. If you extend it, the lever arm intersects A, so it's 0. We all know that. F2, about A, so F2, this one right here, about A. Alright, we extend its lever arm. All we see, this is your distance. So firstly it's going to be 6, which is your distance, times, remember it's counterclockwise, it's going this direction, so it's positive, and we know from the question F2 is 20, so 6 times 20. Actually, sorry, it's clockwise. This is clockwise, my bad. This is actually clockwise, not counterclockwise. My bad, I'm sorry. So it's going to be 6 times negative 20, which is negative 120. My bad for that. Now we take F3, which is here. This is positive, by the way, just so you know. It's going to be like this. So yes, it is counterclockwise, so it's positive. And we know the force is 6, so 6 times, we extend it. Actually, it doesn't need extension. Here you go. This is your distance. So this is your distance. 10 plus 2, which is 12 meters. And you'll get 72. Great. The net torque, okay, it's gonna be, you just add all of those, the total turning effect, and you'll get negative 48. Last question. Alright, let me just take this into a whiteboard. Alright, let's take the other parts of the question. No, my bad. Alright, now we take this part of the question and add to current page. Okay, great. So, okay, let's start. The magnitude of the moment created by the 200 Newton forces. So what they mean by that is that this is the 200 Newton forces. We realize that it's a couple. Why is it a couple? Opposite direction, check. Equal magnitude, check. Their lever arms are parallel, check. Are they not coinciding? Check. So they are a couple. So what's the rule for the moment of a couple? It's going to be either one of the forces, 200, times the distance between them. I forgot to mention, this is the radius. They said it's 10. The inner radius, this is 10. And the outer radius, which they mean this entire section, is 15 centimeters. Here they want it in meters. But we want the distance between both of them. So we want this full part. So it's 15 plus 15, which is 30 centimeters. But we don't want it in centimeters, again meters, so divide by 100, get 200 times 0.3, and there's your answer. Next question. Here you need to keep in mind the net moment is 0. So here we can realize that it's those two forces are acting in clockwise. So that means it will be negative. Here they wanted the magnitude, that's why we didn't say negative. So if this is negative and the net force is 0, don't we need a positive torque? We need a positive turning effect. So what we have to do, the force exerted on A, so this part, it has to move counterclockwise. So not this direction, it has to move this direction. So it has to go leftwards. And since, also for B, it has to be rightwards to maintain that counterclockwise motion to be able to get it to 0. Last question. The magnitude of F is 300. We want to find this F. So we know the total net force is 0. So it's going to be 0 is equal to we know the negative 60. Oh, they want the magnitude, never mind, just 60, or actually negative 60, doesn't matter. Negative 60 plus, you're gonna have this force. So these are the forces, they're also a couple. If you realize, they're the same magnitude, opposite direction, lever arms are parallel, not coinciding, blah blah blah. So we just need the distance between both of them and any force. Alright, so force is unknown, and the distance here, we already know this radius is 10 and we want the diameter, so it's going to be force times 10, force times 10 centimeters, we change it to meters, again 0.1, 0.1, and then we push it to the other side. 60 is equal to F, oh sorry, this is 10 and this 10, so this has to be 20. I am so sorry. So this has to be F times 20 centimeters because we want this completely. Alright, I'll repeat. So we know that the radius here is 10. We want the entire segment. We want the entire segment in between. So it's going to be F times 20 centimeters. We're going to divide by 100. So it's going to be 60 is equal to F times 0.2. Divide by 0.2. You'll get 300. I hope you understood. And I apologize for the bad explanation. And good luck in your exam tomorrow. Thank you.